Here's a fun example. Let's find the Maclaurin series for arctan of x. To do this, we're going to use a special fact about arctan of x, namely, that its derivative is 1 over 1 plus x squared. Why is this useful? Well, let's recall the geometric series. If the absolute value of r is less than 1, then the sum 1 plus r squared plus r cubed and so on will be 1 over 1 minus r. Now, notice that if we set r equal to negative x squared, well then, and that's exactly the derivative for arctan of x. So if the absolute value of r, which is negative x squared now, is less than 1, then we can expand it as a geometric series. We just need for the absolute value of x to be less than 1. If so, then 1 over 1 plus x squared can be rewritten as, let's substitute negative x squared for r. Let's simplify the terms, and we get 1 minus x squared plus x to the 4th minus x to the 6th, and so on. Actually, it'll be simpler to just use sigma notation. So let's just plug in negative x squared for r there. We'll multiply the exponent I so that we'll get negative 1 to the power I times x to the 2i. Okay, so what was the point of all of this? We have a series for the derivative of arctan of x, but we wanted a Maclaurin series for arctan of x itself. How can we get that? Well, to get rid of the derivative, let's just integrate both sides. On the left, we'll get arctan of x, and on the right, we'll apply power rule so that the exponent of x becomes 2i plus 1, and we divide by 2i plus 1 again. And that's our answer for the Maclaurin series of arctan of x. Now, what's the radius of convergence for the series centered around 0? Well, remember we needed for the absolute value of x to be less than 1. Hence, the radius of convergence is 1. You can double check this with the ratio test, which will give you the same answer. Because remember, the intuition for the ratio test comes from the geometric series. As an exercise, let's apply the ratio test. Remember the ratio test. If the limit to infinity of the absolute value of the ratio of consecutive terms is less than 1, then the series converges. If it's bigger than 1, it'll diverge. If it is 1, the ratio test is inconclusive. You can take it from here.